Okay, so yesterday we left off here. Okay. We defined pH and pOH, right? And then we said that H plus, the concentration of H plus times the concentration of OH minus is always going to be 10 to the minus 14th. And if I took the negative log of both sides, I got that next equation. Because the negative log of H plus is pH, the negative log of OH minus is pOH. And since it was multiplication and now I'm changing it into exponents, I have to add them. Right? And the negative log of 10 to the minus 14th is 14. So it's really the same equation. But with those three equations, if I give you any one of the numbers, you can find the other three. Okay? Because if I give you the H plus concentration, you can find the OH minus and the pH. And once you find the pH, you can find the pOH. Or once you find the OH minus, you can find the pOH. Okay? Anytime I give you one of those numbers, you can find the other three. So that's what we're going to work on today. How to push that into your calculator. So the solution has an H plus concentration of 0.01 molar. What is the OH minus concentration? Well, looking at this, hey, I get H plus and OH minus. I have an equation that has those pieces in it. I probably should use that one. Okay, so I'm going to use that equation, and then I need to solve it for OH minus, which means I need to divide both sides by H plus. So 1 times 10 to the minus 14th over the H plus concentration will be the OH minus concentration. Just rearrange that equation. Divide both sides by OH minus, or by H plus concentration. Yeah. So that's 10 to the minus 14th divided by H plus is 0.01, which is 10 to the minus 2. So the OH minus concentration has got to be 10 to the negative 12 molar. Well, you can push it in your calculator if you want to, but I can do that without it. It's faster to do it without it. I move it. Ooh, that's 10 to the minus 2. 14 minus negative 2 is negative 12. Oh. Yeah, because we're doing exponents, right? So you can type it 1e negative 14 divided by 1e negative 2. It'll be 1e negative 12 because it won't try to write it out. What was that? Division is subtraction. So negative 14 minus a negative 2. Minus negative 2 is plus. It's signs of the issue here. They're going to confuse you. You've got to make sure you keep track of those signs. Okay? What's the pH? Well, pH is, by definition, the negative log of the H plus concentration, which is the negative log of 10 to the negative 2. So what power would I have to raise 10 to get 10 to the negative 2? Negative 2. So the negative of a negative 2 is 2.
What's the unit pH?
A pH doesn't have a unit because we don't want to have the log of a unit. It's kind of meaningless. Unit squared makes sense because we multiply them. Log of a unit doesn't work. Yeah. Okay, so how about the log? Okay, so the log of the H plus concentration. H plus concentration is 10 to the minus 2. The log of 10 to the minus 2 is minus 2. Because the log is what power do you have to raise 10 to get 10 to the minus 2? Well, I can raise the minus 2. And since it's a negative of that log, the negative of a negative 2 is 2. So if you push log 1e negative 2, it's going to get you a 2. Or going to get you a negative 2. And a negative of a negative 2 is 2. Yeah. It'll still get you, yeah. To me, no, I do the 10 to the minus 2 so I can do it in my head. I'm lazy. I'd rather do as much as I can in my head because many times the calculator slows you down. Typing that in would be long. It's faster to do it in your head. Okay. What's the pOH? Okay. We have two ways of getting there. Okay. Now we have two ways of getting there. I can either use the negative log of the OH minus concentration, which is the negative log of 10 to the negative 12th, which is 12, right? Or I can use this equation. 14 minus pH has got to equal the pOH. And I can do 14 minus 12, or 14 minus 2 is 12. Either way I do it, I get the same answer, which should be true. So they only gave me one number. I could turn that directly into pH, and then I could take that answer, and then I could take that pH and turn it directly into pOH. Right? Or I could take that H plus and turn the pH, the H plus, turn it to OH minus. Usually OH minus to find pOH. Is this an acid or a base? No, it's one or the other. A solution is either acid, base, or neutral, and this is not neutral. Okay, so how do we know? Acids have more H plus than OH minus. Okay, 0.01 is bigger than 10 to the minus 12th. It's got a lot more H plus than OH minus. Okay? No, it's not basically, it's an acid. Because it's got a pH of 2. Neutral is 7. Lower than 7 is an acid. Above 7 is a base. 10 to the minus 7th is neutral. 10 to the minus 2nd is a lot bigger than 10 to the minus 7th. 1/100th is much bigger than 1/10 millionth. Right? So, now, you say, well, there's a bunch of numbers. Which one do I use? My answer is, I always pick the H ones. I don't try to remember the OH ones. I try to remember the H ones. Because then if they give me the OH ones, I can figure them out. But if I try to remember both, I'm going to get messed up. So I only work on remembering H. Okay? pH low, H plus high. Lots of H plus in an acid. Very low pH for an acid. Okay? I don't try to remember both. I remember one, and I can figure out the other. Okay? So, what if they gave you OH minus concentration? I told you the OH minus concentration is 10 to the minus 5th molar. What is the H plus concentration? Got an OH minus, they asked me for an H plus. I could only see one equation that has those pieces in it. So I'm going to do that the OH minus, the H plus concentration is 10 to the minus 14th divided by 10 to the minus 5th, which is 10 to the minus 9th. Because negative 14 minus a negative 5 is negative 14 plus 5, which is negative 9. Pretty easy. What's your question, Anna? Got it? Okay. What's the pH? I'm too lazy to write 1 times. Okay, so what's the pH? Well, the pH is the negative log of the H plus concentration, which is the negative log of 10 to the minus 9th, which is 9. pOH, I can either do the top equation, do the negative log of OH minus, or I can do the bottom equation. I like the bottom equation better. I can do that subtraction a lot faster. pOH is going to equal 14 minus pH, which is 14 minus 9, which is 5. Is it an acid or a base? Base, because the pH is high, it's a base. So notice how focusing on just one side of it makes it really easy to pick which one's the acid or the base. Trying to think about all the numbers at the same time, you get confused. Focus on H's and pH's, should be okay. Okay, these are ones I didn't, notice I haven't picked up a calculator yet. So now let's figure out how to do the same kind of problems when I need a calculator. A solution has a pH of 3.07. What is the H plus concentration? This one requires you remember how to do math with logs. Okay, so remember pH is the negative log of H plus. So if I want H plus by itself, first I got to move the negative. So negative pH equals the log of H plus. Look at that. And now I need to do the opposite function of log. What's the inverse function of log? It's 10 to the x. So the H plus concentration is going to be 10 to the minus pH. That's going to work out every time. The OH minus concentration is going to be 10 to the minus pOH. The pH is the exponent because it's a logarithm, so it's got to be an exponent. Isn't that what logarithms are? So if that's the case, then I do 10 to the minus 3.07. Push along with me and make sure we all hit the right buttons, because you don't want the magic button this time. You want 10 to the power of negative 3.07. If you push it, your calculator is going to fill up with numbers. Okay? And I got my calculator say 8.511 times 10 to the negative 4th molar. Everybody okay getting that on your calculator? You can get that on your calculator. Anybody not able to get that? Okay, now we think about sig figs. Remember yesterday we did all that stuff with 2 and found out the 2 showed up here and the 100, the 1,000, the million showed up in the 3, right? So sig figs are only after the decimal point. So this has 2 things after the decimal point. That means it has 2 sig figs. A pH with 2 numbers after the decimal point has 2 sig figs. Because the number in front is telling me where the decimal point is, 10 to the 2, times 10 to the whatever the decimal is. So it'd be 10 to the negative 3rd plus 10 to the negative 0.07. And the 0.07 would have 2 sig figs. So with 2 sig figs, it's 8.5 times 10 to the negative 4th. So it only has 2 sig figs because it only has 2 numbers after the decimal point. because the numbers after the decimal point tell me the blank times 10 to the x. And the blank is where all the sig figs are. Logarithms are really just a short way to write scientific notation. Okay. What's the OH minus concentration? Well, this is going to be easy now to know the H plus concentration. That's going to be 10 to the minus 14th divided by 8.5 times 10 to the negative 4th equals, okay, so let's type this in, 1 EE negative 14. That's how you type in 10 to the negative 14th. 1 EE negative 14th, 1 times 10 to the negative 14th, divided by, I'm not going to type it because it's sitting in my calculator. I just typed it a second ago. Divided by the answer gets me, with 2 sig figs, 1.2 times 10 to the negative 11th. Everybody get those numbers to show up? Okay, quick check. When you got just ones, the coefficients always add up to, the exponents always add up to negative 14. When you got numbers in front, they're always going to end up to negative 15. Because 8.5 times 1.2 is 10. And 10 times 10 to the negative 15th is 10 to the negative 14th. So the exponents are always going to add up to negative 15th if there's not ones in front. So that's a quick check that you're, okay, because that's 10 times 10 to the negative 15th when you multiply them together. Okay? And the pOH? So these exponents here are going to add up to 10 to the negative 15th every time, unless there are ones in front. Like last time, if you look at the last two examples, they add up to 10 to the negative 14th because it was all ones. pOH equals 14 minus pH. That's the lazy way to do it. 14 minus 3.07 gets me 10.93. Ta-da. Or I could have done the negative log of 1.2 times 10 to the negative 11th. If I type negative log of the answer on my calculator, I get 10.93. It's amazing. Okay. And is this an acid or a base? What are we looking at? We want to look at pH or H plus, one of the two, right? So we want to look at the H side. My pH is low. My H plus, 10 to the minus 4th, sounds little, but it's bigger than 10 to the minus 7th, right? So this is an acid. It's bigger than 10 to the minus 11th. You're going to have more H plus than OH minus if it's an acid. Makes sense? Okay. And so if a solution has a pH of 5.63, what is the OH minus concentration? Using the same inverse function that we did for the pOH, we're going to end up with 10 to the minus pOH equals pOH, or equals OH minus. Move the negative sign over, do the opposite function, you get 10 to the minus pOH. So that's 10 to the minus 5.63, 10 to the negative 5.63, gets me 2.3 times 10 to the negative 6 molar. So negative 5.63 is a little bit bigger than negative 6, 2.3 times what negative 6 is. So you just got to move the negative over and do the inverse function. What's H plus? Well, the H plus is going to be, I'm going to use that equation, so it's going to be 10 to the minus 14th divided by OH minus, which is 10 to the minus 14th divided by 2.3 times 10 to the negative 6th. One times 10 to the negative 14th divided by answer, because it's already sitting in my calculator. I get 4.3 times 10 to the negative 9th. Once again, we get that negative 15th in the exponents. Somebody get something different?
Yeah, I got
At 4.0. Oh, no, okay, did you push answer or did you push divided by the answer, or did you type in 2.3? See, that was me being lazy and not typing in 2.3. I already had it sitting in my calculator. Why would I round twice?
I probably just don't know how the calculator works.
I just pushed divided by answer. I still get 4.3 times 10 to the negative 9th. Yeah, it should be 4.3 times 10 to the negative 9th. It's a 2.3, not a 2.5. Everybody get 4.3 the second time? It should be 4.3. 1 E negative 14 divided by 2.3 E negative 6. What? Yeah.
Mine is weird. I don't know if I have this wrong, but it says 4.3 fills up with numbers at the end of E negative 21.
Okay, so you forgot the negative on the 6th. Then you didn't use scientific notation. You pushed times 10 to the. You didn't push the E button.
I pressed the E button.
Okay, we'll have to look, see what happened there. Okay, pH. What's your,
I have no idea what just happened.
no, okay, so 1 EE. I have no idea where they got the other one. What button you push where it didn't leave a space there? 1 E negative 14 divided by 2.3 E negative 6 equals.
Okay, I've been pressing the wrong button this whole time.
Okay.
I've been
Oh,
okay.
I know what it is. Hey, now I see what happens. You guys got a whole screen full of zeros, then a 4.
Yeah.
So does that mean there's nothing after the 4?
No.
Okay, so how can you fix that? Well, you can either take the time to turn it into scientific mode on your calculator if you figured it out, or all you really need to know is how many decimal places and what the number is after that 4. So multiply by 100, it will show you the numbers after the 4. They're still there. It still carried them. They're still there. It just can't put them on the screen. Does that make sense? If you multiply by 100, it'll move it over a couple so you get to see what those digits are.
I don't know how I got the right answer, but I this whole time.
Well, the other ones we were pushing 10 to the. Yeah, but not 1 times 10 to the. So we were using just the 10 to a power.
Okay.
Everybody get a pH of 9.37? It's 8.37, you're right. Okay, how would I get that? What could I use to figure out pH? Or the lazy way, so I can do it in my head. Once I know the pOH, the easy way is to subtract it from 14. I don't need a calculator. Okay? But if I take the negative log of 4.3 times 10 to the negative 9th, I'll get the same answer. And is it an acid or a base?
It is a base. It's a base.
8.37 is bigger than 7. They all just trying to bask in it. Okay. What if they don't tell you the H plus concentration? Instead, they tell you the acid's concentration. What is the pH of 2 molar HCl? Okay. Well, if I got HCl, HCl is going to fall apart into H plus and Cl minus. And all of it's going to fall apart. So if I start off with 1 molar HCl, there's no HCl. Actually, there's no H plus, there's no H plus either. There's H3O plus. But H3O plus is going to be the same concentration. If I had 1 mole of HCl, it would fall apart into 1 mole of H plus and 1 mole of Cl minus. So by telling you the concentration of the acid, they're telling you the concentration of H plus. So a 1 molar solution of HCl would have 1 molar H plus concentration, and its pH would be 0. Say, whoa, how do you get 0? 10 to what power gets you 0? Or 10 to what power gets you 1? 0. Right? 10 to the 0 is 1. This has got to have a pH of 0. Okay. What's the pH of 0.032 molar nitric acid? Well, it's HNO3. When it falls apart, it's going to make an H plus. So my H plus concentration has got to be 0.032 molar. So my pH is the negative log of 0.032. And that is 1 point, how many sig figs? 0.032 has 2 sig figs. So I need 2 sig figs in my answer. That means I need 2 decimal places. So it's 1.49, because there's a 4 after that 9. Leave the 9 alone. Math's not different. You just have to be able to translate that the HNO3 is going to make H plus. Okay. Let's try it with bases. Well, bases fall apart to produce OH minus. So by telling you the base concentration, I'm telling you the OH minus concentration. So NaOH makes Na plus OH. So 2 molar NaOH is really going to make 2 molar OH minus. Which would give it a pOH of, we did this math yesterday, 0.30, right? The negative log, the negative 3.30. The negative log of 2, we took the log of 2 yesterday, was 0.30, right? Right? Everybody remember that from yesterday? So that means the pH of this is 14.30. because 14.30 plus negative 0.30 equals 14. pHs do not stop at 14. You can have pHs above 15. Yeah, so in the past they told you they stopped at 14. No, they don't. Heck, making 2 molar sodium hydroxide is pretty easy. Okay. Complication with bases. Calcium hydroxide does not make 1 hydroxide, it makes 2. So 1 molar calcium hydroxide solution is going to be 2 molar OH minus. Which is, we talked about that, we talked about how many ions they made. It's that same concept. That the molarity of the ions is going to be some multiple of the molarity of the solution. Falls into 1 piece, you got the same number. 2 pieces, you got twice as many. Okay. I'm done talking. Okay, so some acid-base practice, there's some math, there's some labeling. Yeah. Because pH plus pOH has to equal 14. The pOH is negative 3.30. What plus negative 0.3 equals 14? 14.3. Yeah. Oh, another one? There's one. Eli can give it to him. Eli's got an extra. Anna, you can grab one from Eli. If, okay. I didn't want you to be without it. Okay, so first part, the table. I suggest not that you work up and if you work up and down, you'll get really good at that, and you'll move on to a different problem. Get good at that, do a different problem. I would not suggest that. I would work across, so I get used to changing all one into all the other 3. Does that make sense?